Imagine a child, just staring blankly at their math homework. They're fidgeting, they really can't focus on the numbers.
Oh, yeah, we have all seen that.
Right, and your instinct might just be to make them sit completely still and stare at that page until the worksheet is done.
Which honestly usually backfire.
Exactly. But what if the actual cure for their distraction is 20 minutes of playing the Nintendo Wii?
Sounds entirely counterintuitive, I know.
It totally does. But today we are looking at something that fundamentally rewires how we understand the developing brain. We are jumping into a brand new, highly rigorous paper for this deep dive.
And it is a fascinating one.
Yeah, it's titled The Effects of Physical Activity Interventions on Children's Perception, a Systematic Review and Meta-Analysis.
That is a mouthful, but a very important mouthful.
For sure. And we definitely want to credit the authors here. It was written by Zhao, Changqing Xiang, Tengku Fadilah, Tengku Kamalden, and Luo.
Right.
And this was just published in the Journal of Sports Science and Medicine in 2024. So it's incredibly recent.
It really is a massive and essential piece of literature. Because what this research team did was gather the absolute highest quality research from around the globe.
Just to answer one specific question, right?
Exactly. They wanted to know, how does physical activity alter a child's perception?
Wow.
Yeah. And we aren't talking about, lowering their mile time or increasing muscle mass.
Right, the typical gym class stuff.
Exactly. We are talking about mapping how exercise literally alters their psychological and cognitive framework.
Okay, let's unpack this, because I want to start with that word perception.
Sure.
Because I think in everyday conversation, when I hear the word perception, I immediately just think of the basic 5 senses.
Right. Vision, hearing, that kind of thing.
Yeah, exactly. Vision, hearing, touch, smell, taste. Like I see a soccer ball, or I hear a coach blow a whistle.
Right.
But the researchers aren't just talking about a kid having 20/20 vision here, are they?
Not at all.
Yeah.
In the scientific community, perception is not just the raw, passive intake of sensory data.
Okay, so it's more than just the eye seeing the ball.
Yes, it is the active processing, the interpretation, and really the rapid understanding of that sensory information.
Oh, I see.
Yeah, it's how the brain takes a totally meaningless visual input, say a white sphere getting larger in your field of vision, and interprets it.
Right, like, oh no, a ball is flying toward my face at 20 miles an hour.
Exactly. And not just that, but I need to calculate its trajectory and either catch it or duck.
That is a lot happening in a split second.
It is, and that processing speed is the foundational bedrock of higher cognitive functions.
Wow.
You simply cannot have executive control, sustained focus, or complex decision-making without a finely tuned perceptual system.
So it's really the ability to adapt to changing tasks or problems based on how you actively perceive the world around you.
Spot on.
That makes a lot of sense. Now, the researchers focused entirely on children aged 6 to 12 for this study.
Yes, middle childhood and pre-adolescence.
Right, but why zoom in on that specific 6-year window? I mean, why not study toddlers or, teenagers?
Well, because developmental psychologists and neuroscientists recognize that specific period as a massive transitional stage in the human brain.
Okay.
The authors of the paper actually describe it as the transition from non-arbitrariness to arbitrariness.
Okay, pause.
Yeah.
Non-arbitrariness to arbitrariness is a major mouthful.
It is very academic, I will give you that.
And frankly, it doesn't mean much to me. What does that actually look like if I'm, say, watching an 8-year-old on a playground versus a 3-year-old?
Fair point. So think of a toddler or a preschooler. Their reactions are non-arbitrary.
Meaning they just react.
Completely reactive and impulsive. If they feel hungry, they scream.
Right.
If they see a shiny toy another kid is holding, they just grab it. Their behavior is directly dictated by immediate external stimuli or basic internal drives.
Okay, that paints a very clear picture of a 3-year-old.
Yeah. But right around age 6, a child starts transitioning into arbitrariness. They begin to understand complex, abstract concepts.
Oh, like rules of a game.
Exactly. They can consciously regulate their behaviors. They start observing a game of Foursquare, figuring out the complex rules, and understanding that if they break a rule to get an advantage, well, there are social consequences with their peer group.
Oh, wow. So they learn to delay gratification.
Yes. It is the absolute critical window for the development of both physical motor skills and these advanced conscious perceptual abilities.
So if age 6 to 12 is like a massive software update for the brain,
That's a great way to look at it.
then physical activity almost sounds like it's the beta testing phase. Like the brain has all this new complex software for reasoning and logic, But it doesn't know if there are bugs until the child actually goes out, runs, jumps, falls, and interacts with the physical world.
If we connect this to the bigger picture, that beta testing analogy is exactly what is happening neurologically.
Right.
Yes. Motor acquisition and physical activity rely heavily on brain maturation and environmental experience. But it is a two-way street.
How so?
Well, when a child engages in physical activity, they are forced to mobilize multiple perceptions simultaneously.
Like tracking a ball and listening to a coach at the same time.
Right. They have to calculate motion perception, listen for teammates, and execute complex spatial movements. They are actively figuring out up and down, left and right, fast and slow.
And to doing it all in real time under pressure.
Exactly. By feeding the brain these rich, complex, challenging physical experiences, they are testing and optimizing that new operating system. It really forms the biological basis for their ongoing mental development.
Okay, but claiming that running around on a playground literally changes the brain's software is a pretty massive claim.
It is.
How do we know this isn't just a placebo effect from kids just having fun and burning off sugar? I mean, we've heard that exercise is good for kids for a century.
True.
How did they actually prove the neurology here? Let's talk methodology.
Well, they proved it by being incredibly strict with their data. They didn't just guess or, rely on gym teacher anecdotes.
Right.
The researchers initially sifted through 1,815 different studies using PRISMA guidelines.
Which stands for Preferred Reporting Items for Systematic Reviews and Meta-Analyses.
Yes.
But what does that actually mean for you, the listener? Why should we care about PRISMA?
Because it is a structural safeguard against bias. It forces researchers to transparently document exactly how they searched for studies, why they kept some, and why they threw others out.
Okay, so no cherry-picking the data.
None at all. They aggressively filtered those 1,800 studies based on strict inclusion criteria.
And what did they end up with?
They were left with just 12 randomized controlled trials encompassing 1,761 children.
Wait, ending up with just 12 trials out of nearly 2,000 sounds like they threw away a massive amount of data.
It does sound like that, yeah.
Why is that massive reduction actually a good thing for this research?
Because of the scientific weight of a randomized controlled trial, or RCT, a lot of the studies out there on exercise are merely observational.
Okay, meaning what exactly?
Well, an observational study might look at a group of kids who play competitive soccer and conclude, wow, these kids have great executive function, therefore soccer makes you smart.
Ah, but that's just a correlation.
Exactly. Maybe kids who inherently have great executive function and focus are just naturally drawn to the strategic nature of soccer. We don't know the cause.
Right.
But an RCT is a highly controlled experiment. You take a group of children, randomize them, and put one group into a very specific active physical intervention.
While the other group just sits around.
Basically, yeah. The control group gets a non-active or sedentary program.
Yeah.
This completely isolates the physical activity as the sole variable.
Oh, that makes sense.
So when you see a cognitive change in an RCT, you can confidently say the physical intervention actually caused the psychological outcome.
That is huge. And the outcomes they were measuring were divided into 3 main buckets of perception, right?
Yes, 3 specific buckets.
Bucket 1 was body perception and global self-worth. So basically, how a kid views their own physical self and their overall foundational self-esteem.
Right.
Bucket 2 was the perception of motor and sensory abilities, and Bucket 3 was visual perception and executive function.
Exactly.
And if you are listening to this right now, here is where this data turns into a highly practical blueprint.
It really does.
Because the researchers didn't just confirm that physical activity improves these buckets. They found a fascinating Goldilocks effect regarding time.
Yes, the duration variable.
Right. The specific duration of the activity completely changes which bucket in the brain gets the upgrade.
This is where the study gets incredibly nuanced and highly applicable. We have treated exercise as a monolith for way too long.
Like, just go play outside for an hour and you're good.
Yeah, right. But let's look at the data. For sessions lasting 30 minutes or less, the researchers found the absolute greatest impact on visual perception and executive functioning.
Wow, under 30 minutes.
Yes, and the effect size was huge. They noted a standard mean difference, or SMD, of 1.33.
Let's translate that statistic because SMD can sound a bit dry.
Please do.
An SMD of 1.33 isn't just a slight bump. In the statistics world, anything over a 0.8 is considered a massive, highly significant shift.
It's a massive result.
That means a child doing 20 minutes of specific exercise is showing a night and day difference in their ability to focus, plan, and process visual information compared to a kid who is just sitting still.
Precisely. It is a profound neurological shift. But then, if a session lasts between 30 and 60 minutes, the data shifts.
Okay, what happens then?
That middle duration was found to be the most effective for promoting bucket 2 motor and sensory perception.
Ah, okay.
And then if the session stretches beyond 60 minutes, the cognitive benefits shift entirely again.
The last bucket.
Yep. Those longer sessions were the absolute best for boosting body perception and global self-worth.
Hold on, I have to push back on this because it feels totally backward.
How so?
You're telling me that a quick 20-minute game of tag does more for a child's executive function than a rigorous hour-long soccer practice.
That is what the data shows.
But if longer is better for cardiovascular fitness, why isn't an hour better for the brain's focus? Like, why would a 20-minute session massively boost executive function while it takes over an hour to change how a kid actually feels about themselves?
What's fascinating here is the distinct psychological and physiological demands of those different time frames.
Okay.
Think about what usually happens in a 20 or 30-minute burst of physical activity. It is rarely a slow, methodical jog.
True. Kids are usually sprinting around like crazy.
Exactly. It is usually a high-intensity game, a sprint, or a highly focused task. Short bursts require rapid visual tracking, quick decision-making, and intense, unbroken focus.
Oh, they are constantly reacting.
Yes. The child has to immediately interpret spatial boundaries, dodging a friend, catching a ball, and react instantly. That is pure, concentrated executive function training.
Oh, I see.
It's a high-intensity cognitive processing.
So it's like a sprint for the brain's decision-making center. And I guess they physically and mentally just can't sustain that level of hyperfocus for a full hour anyway?
Right. The cognitive load is just too high to maintain. The brain fatigues just like the muscles do.
That makes total sense.
But conversely, global self-worth and body perception are incredibly complex psychological constructs. You don't rewire your foundational self-esteem in 15 minutes of an elevated heart rate.
No, definitely not.
Longer sessions require sustained effort. They require endurance, pushing past initial physical fatigue, and ultimately, skill mastery. Furthermore, sessions lasting over an hour usually involve deep social dynamics.
Right, you're working with the team, you're getting ongoing feedback from a coach or peers.
Exactly.
You're dealing with the frustration of losing, the high of winning.
Yes, you are experiencing a complete narrative arc of struggle, adaptation, and success. That prolonged engagement gives the child the necessary time to internalize their physical competence. They have to live in their body, sweating and working, long enough to truly appreciate what it can do.
And that sustained realization is what actually builds global self-worth.
Exactly.
That completely changes how you would design a physical education class or even just a weekend activity, depending on what the child actually needs that day.
Absolutely.
Like, if you're listening to this on your commute right now, you might be thinking, great, I need to force my kid to exercise for exactly 45 minutes to hit that middle bucket.
Right, treating it like a recipe.
Exactly. But the study warns against treating this like a rigid prescription for every single child, because they also proved that the type of child participating dictates the most dramatic benefits.
Yes, the subgroup analyses were incredibly revealing.
Yeah, the data showed that physical activity has a profoundly transformative impact on two specific populations of children. First, obese and overweight children.
Yes. For obese and overweight children, the data shows that physical activity has a significantly higher impact on body perception and overall self-worth compared to the control groups who had no physical activity.
Which is huge.
It is, and we have to contextualize the mechanism here. Obesity is a major public health issue, but it comes with a heavy psychological burden.
Definitely.
Due to societal factors, peer pressure, and stigma, these children often experience a severe decrease in their self-esteem and internal perception of their body image.
Because they are constantly receiving external signals that they don't measure up.
Exactly.
Which naturally degrades that global self-worth bucket we talked about. They are starting from a deficit.
That is exactly right.
Yeah.
But through structured physical activity, and the studies use things like curriculum-driven aerobics and circuit training, these children exercise their temporal, spatial, and motor perceptions.
They learn how to move effectively.
Yes. They learn to physically control their bodies in space, and as they master those movements, they regain a sense of agency.
And that agency fights the stigma.
Exactly. That agency directly combats the decreased self-esteem. They realize their body is capable, strong, and functional.
I love that.
Reclaiming that physical agency is why the boost in global self-worth is so dramatically higher for this subgroup compared to their peers.
And the second specific population the researchers highlighted was children with DCD, which stands for Developmental Coordination Disorder.
Right.
For anyone unfamiliar, DCD is a condition where a child has significant difficulty with motor coordination compared to other kids their age.
Yes.
They might seem unusually clumsy, have trouble tying their shoes, or really struggle with catching a ball. But the meta-analysis found that for children with DCD, physical activity profoundly enhances not just their motor and sensory abilities, but also their executive function and attention.
It is a remarkable finding. Motor acquisition relies on brain maturation. For a child with DCD, participating in physical activity forces them to consciously mobilize their sensory inputs to complete complex movements that might come automatically to a neurotypical child.
That makes a lot of sense.
And the specific interventions used in these 12 studies to achieve this were so diverse and fascinating.
Yeah, I want to unpack the actual activities used because it wasn't just making kids run laps around a track.
No, very well.
They looked at studies that used indoor wall climbing, circuit training, plyometrics, and taekwondo.
Which is brilliant when you think about it.
It really is, which, if we think about the mechanism, makes total sense. Take taekwondo, for example.
Okay.
A kid learning a martial arts form isn't just throwing random punches. They have to memorize a complex sequence of movements, balance on one leg, calculate the spatial distance to their opponent,
And execute fine motor control to stop a kick an inch away from a target.
Exactly. It is forcing neural pathways to fire in a rapid, highly coordinated sequence, tying physical movement directly to cognitive recall.
Absolutely.
The intervention that completely shocked me was active video gaming, exergaming.
Oh, yes.
Using things like the Nintendo Wii Fit or the Xbox Kinect.
This raises an important question about how we fundamentally view screen time.
Oh, for sure. We always hear screen time is bad.
Right. We constantly dichotomize the physical world and the digital world, assuming digital is inherently sedentary and bad for the brain. But exergaming bridges that divide.
How so?
Think about the cognitive load of a game on the Xbox Kinect. A child has to stare at a digital interface, interpret the visual data like the speed of an object or the layout of the screen, and immediately translate that into physical movement in the real world.
That is a lot of processing.
It is. They must distinguish left from right, understand spatial boundaries up, down, fast, slow, and perfectly time their physical actions to match the digital demands.
Oh, I see the mechanism there. It is because the digital avatar fails immediately if they move wrong.
Exactly.
If you swing the Wii remote a fraction of a second too late, your character misses the tennis ball instantly. So neuroplasticity is forced in real time to correct the physical mistake.
Yes.
The game is basically tricking the brain into doing high-level executive function training.
That instant feedback loop is the key. A human gym teacher cannot possibly provide feedback that fast.
No way.
That immediate digital feedback forces the brain's perceptual centers to adapt and improve rapidly. And because it is a video game, it is highly engaging.
So they actually want to do it.
Exactly. The child willingly sustains the attention required to force that neuroplasticity. The study specifically noted that Wii Fit training significantly improved visual perception and executive function in boys with DCD in just 8 weeks.
Wow.
8 weeks to measurably upgrade a child's cognitive software using a video game.
So what does this all mean? If you are taking anything away from this deep dive, the absolute key takeaway is that physical activity should no longer be viewed as just a generic way to go outside and burn off energy.
Right. It has to be more targeted than that.
It shouldn't be random. It needs to be intentionally designed.
Right.
If you are an educator building a curriculum or a parent trying to support your child, you have to factor in duration and the child's specific physical or psychological needs to optimize their cognitive and perceptual growth. Like, if your kid is struggling with focus before homework, a 20-minute intense exergaming session on the Nintendo Switch, or a quick, complex game of tag in the yard might be exactly the executive function boost they need to sit down and do math.
Yes.
But if you want to build their resilience, their body image, and their foundational self-worth, you need to carve out the space for those sustained 60-plus minute sessions where they can struggle, adapt, and master their environment.
And we also have to look at where this research is heading next.
Oh, I'm curious.
This meta-analysis was incredibly rigorous, but the authors noted a limitation.
Which was?
The current research largely relied on subjective questionnaires and rating scales to measure these shifts in perception.
Ah.
Self-reporting is valuable, but it has inherent biases. Kids might just say what they think the researcher wants to hear.
True, kids do that all the time.
Right. But what happens in the near future when we start using advanced biometric sensors? Imagine a physical education class where children wear non-invasive sensors that track real-time perceptual shifts, eye tracking, and neurological engagement during play.
That sounds like science fiction.
It does, but it's coming. We will be able to quantitatively map exactly when a child's executive function peaks during a game of tag, or exactly how long it takes for a child with DCD to achieve a state of flow in an exergaming session.
That would change everything.
How will having that real-time objective data change physical education curricula forever? It will become as precise as prescribing medicine.
That is an incredible thought to leave on. The idea that recess might eventually become a highly tailored, biometrically optimized cognitive intervention.
It's fascinating.
We could prescribe a specific game of capture the flag to treat an attention deficit. It really shows how far we've come from just handing out a dodgeball and blowing a whistle.
We have come a very long way.
Well, if this conversation sparked your curiosity and you want to see the underlying data for yourself, I strongly encourage you to read the full article. The Effects of Physical Activity Interventions on Children's Perception, a Systematic Review and Meta-Analysis.
Highly recommend it.
The statistical methodologies, the specific trial breakdowns, and the granular details on those subgroup analyses offer a wealth of knowledge that we really only scratched the surface of today.
For sure.
And of course, please remember to follow the channel and turn on notifications. We are dedicated to bringing you these scientifically rigorous, accessible deep dives into academic research, helping you stay at the cutting edge of human performance and psychology.
Absolutely.
To circle back to where we started, childhood isn't just about growing taller. It is a massive, complex operating system update. And now we know that the best way to make sure that new software runs perfectly isn't just sitting still in a classroom. It's getting out there, moving, and beta testing the code. Thanks for joining us. We will see you on the next deep dive.